In this video, we will look at the gradients of some special lines. The special lines are horizontal lines, vertical lines, and parallel lines. First, let us look at this horizontal line. By now, you should know that for a horizontal line, the y values of all points on the line are the same. In this case, the value of y is positive 1. This means that there is no change in the rise. Hence, the rise is 0. For the run, the horizontal distance is 5 minus 2, that is 3 units. Since the gradient is given by rise over run, the gradient of the horizontal line is 0 divided by 3, which is equal to 0. Therefore, the gradient of a horizontal line is always 0. Now, let me ask you a question. In order to find the gradient of a horizontal line, do we really need to calculate the run? You should be able to see that for a horizontal line, the rise will always be 0. And we know that 0 divided by anything is always 0. Hence, regardless of what the value of the run is, the gradient of a horizontal line will always be 0. Next, let us look at a vertical line. You should be able to see that for a vertical line, the x values of all points on the line are the same. In this case, the x value is 1. This means that there is no change in the run. Hence, the run is 0. As for the rise, the vertical distance is 3 minus negative 2, that is 5 units. Since the gradient is rise over run, the gradient is 5 divided by 0. We know that this cannot be defined because 0 cannot divide any number. Therefore, the gradient of a vertical line is always undefined. Now, what can we say about lines with the same gradient? Here we have two lines, AB and PQ. Let us take a look at the rise and the run for these two lines. Notice that the steepness of the lines is the same, as given by the corresponding angles. Therefore, they must have the same gradient. Now, let us observe what happens to the two lines when they are extended. Can you see that the two lines are parallel to each other? Therefore, an important property is that lines with the same gradient must be parallel. The opposite also holds true. That is, if lines are parallel, they have the same gradient. In summary, the gradient of a horizontal line is 0, the gradient of a vertical line is undefined, and parallel lines have the same gradient.